Do you know how to construct a polynomial source in SPICE? Do you know how to construct the voltage controlled sources in SPICE? Do you know how to construct the current controlled sources in SPICE? Stay tuned till the end of the video to know all the answers. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the polynomial source of one dimension. Next, we will talk about polynomial source of two dimension. Obviously, we will give examples so that you can understand and correlate the syntax with the example. Next, we will talk about the voltage controlled voltage source with an example. Next, we will talk about voltage controlled current source with example. Going further, we will talk about current controlled current source with example and current controlled voltage source with example. And that's the menu for today. Without any further delay, let's begin. Before going any further, I would like to emphasize a point that in today's episode, we are going to discuss about the dependent power source. That means the power source which we are using to empower our circuit is dependent on some sort of other sources, functions, etc., etc. And that we will go and explore today. So let's move on. First is the polynomial 1D source. That is the one-dimensional. So here you can see that couple of friends are standing together and we will see similar thing as for the coefficients. Here it is the syntax, it is E, the first letter, and there will be alphanumeric that you can specify, and then there will be plus node, minus node, then degree of variables, then the plus node, minus node, and then there will be polynomial coefficients. So what does this syntax mean and corresponds to? The independent voltage source is here V, which is connected in between plus n and minus n, and the equation of the one-dimensional polynomial source is, you can see y equal to p0, then a, p1 into a square, and that's how it goes on up to pn a to the power n. So this is the polynomial equation, and this voltage will be put as a, and these coefficients are this. This is why you can see plus n minus n is here, and all these coefficients are put after that. For the polynomial equation this, we will have the SPICE equivalent this. Now let me explain and map how this is going on. So E1 is the syntax from here, which is connected in between plus n and minus n. So the two positive and negative node in between the control source is connected is 5 and 0, and we have a polynomial of degree 1. So here it is the degree. Here you can see degree or number of variables. And then we have plus n minus n. Here you can see this voltage is connected in between 3 and 2. So 3 and 2 comes here. And you can see here the coefficient P0 is 1 and coefficient P1 is this. So here two coefficients are mentioned. So this way one-dimensional polynomial equation is formed here through the SPICE syntax. This is a bit difficult or complex as compared to the independent sources. You have to put your mind calm and quiet manner, and then you have to think and correlate. So this is something which is much more complex in nature than any other sources, independent sources you have seen before in last episode. We are done here with the polynomial 1D source, that is one dimensional. Now we'll move on to the next slide. Here we will talk about the polynomial source that is two dimensional. So here you can see there are two rows of coefficients, that is two dimensional, and this is just a kind of graphics I kept here. Here the syntax is E, then this X will be alphanumeric, positive node and negative node in between the source is connected to m power, and then we will have the degree of variables, and then we have node 1, node 2, then we have n1 plus and n1 minus and n2 plus and n2 minus. Because this is 2D, there will be two sources and there will be couple of coefficients that defines the equation. Now let us proceed to understand it more. So here the independent voltage source are, this is V1 which is connected in between node 1 and node 2, you can see, and V2 which is connected in between the node 2 plus and node 2 minus. And here it is node 1 plus and node 1 minus. So these are the two voltage sources. These are the independent sources which are controlling this dependent source, right? For two-dimensional polynomial, the equation is, it's a bit complex than before. P0 has nothing here. Then P1 into A, P2 into B, P3 into A square, P4 into AB, P5 into B square, P6 into A cube, P7 into A square B, P8 into AB square, P9 into P cube. So, and this goes on. And for this particular polynomial, V10, 3.3 into V32 and 4 into V square. Now this is A and this is B, and you can see here this resembles to this and this resembles to this, and we do not have any other coefficient. So these rest of the things are not here, so we will not think about them and not talk about them. However, you can see this is 0, this is 0, this is 0 and this is 0. So these are absent completely. This happens only these coefficients are 0, P2, P0, P2, P3, P4. Now let us see the spice equivalent. Here the spice syntax is E1, which is connected between 1 and 0. These two is a poly of order 2, and here we degree on number of variables. Then we have 3, 2, which is these two nodes. These two nodes are these two nodes, and 7, 6 are these two nodes here. And then you can see P0 is 0. This is 3 because here it is 3, and here this is P, right, and B square, and this is P5. So P5 here goes 4, and in between we have 1, 2, 3. Zeros, 3 zeros are here. So this way the polynomial is constructed with the spice syntax. The independent sources A here is V32 as we have seen, right, and B is V76, and here A and B are also in the equation. So you have to correlate in a very calm and quiet manner, and this is very different from the previous episode sources where we talked about the independent sources, and here dependent sources are much more complex in nature in mathematical form. The polynomial coefficient, as I explained, P0 is 0, P1 is 3, then we have 3 zeros, and P5 is 4. I have already explained this. So we are done here talking about a two-dimensional polynomial source. Now let us move on. Voltage controlled voltage source. So here goes our syntax. So this is E, and it would be alphanumeric, node 1 and node 2 in between which it is connected. We give a type, then we have again the independent sources is here in between these two nodes, then gain, max value, mean value. These are upper and lower caps of the voltage. Let us see through examples. The type can be, this type can be VCVS, op-amp, transformer, PWL, poly. Max and mean are the two upper and lower capping limit of the output voltage. The output voltage, the capping limit is here. Behavioral voltage source syntax is E, then XXX, then we have plus N and minus N, right? These two nodes, then volume, then equation. Then again we have the two nodes in between the voltage is connected, then max value, mean value. Example, VCO. We have EVCO, which is connected in between two nodes, and the equation is like this. We have the equation. Ideal op-amp syntax is here E, then we have alphanumeric presence here with the 3 x's, and then we have two nodes, op-amp, then plus and minus nodes. So example is op-amp, then we are connected between 2 and 3, op-amp is mentioned here, it is again two nodes are there, max is 5, mean is minus 5. So max and mean we are saying the capping limit. Next we have the transformer. Transformer is something, there we have two coils, right, and in between we have something for the separation. So this induces this getting induced by this. So here we have the format, we have two nodes, then transformer, then plus minus nodes. Here key is the mutual inductance. Example is E trans, then out 0, then we have transformer, then in 0, and the mutual inductance is 10. This way we write the voltage controlled voltage source. That means the source which is controlling is a voltage, and that the source which is getting controlled is also a voltage. We have given multiple examples, and these are complex sources. Obviously you have to put your mind in a calm state to understand the syntax and correlate, right? Not like the previous independent sources which we have talked in last episode. So we are done here. Let's move on to the next slide. Now we talked about voltage controlled current source. These are current source and these are controlled by voltage. The syntax will be like this. Here we have G, then alphanumeric presence here, then two nodes, then type, then again we have two nodes where the independent source is there, then we have the transconductance and max and mean value. Now let us go in detail The type can be VCCS, VCC cap, and VCR, PWL, poly, PPWL, bidirectional switch of PMOS, and NPWL, bidirectional switch of NMOS. So here we have a what? PWL, and you will see in the example how this PWL is signified through the code. Max and mean are the upper and lower capping limit of the output voltage. That means this one, right? Resistor switch, let us see an example here. A voltage controlled resistor represent a basic switch characteristics. How? Here G switch is connected between 2, 0, and this is type VCR, voltage controlled resistor, and PWL. Now it is connected 1 and 0, and here the PWL is controlled within the limit 0 volt and 10 meg, 1 volt and 1 meg. Beyond the voltage capping levels, the resistance values are 10 meg and 1 milliohms respectively. In between, it varies linearly. We have the upper limit and lower limit, and we have a voltage controlled resistor. MOSFET switch, now we will go in these switches, right? Here, G and MOS is connected between D and S, VCR, this is VCR, NPWL, right? Where this, next we have these two, these are again G and S. Now MOSFET level is 1, and then we have 0.4 volt, 1 pi E, 1 volt 10 meg, 2 volt 50K, 3 volt 4K, 5 volt 2K. Now let us see. Here a MOSFET switch is modeled by N piecewise linear resistance switch. Voltage controlled capacitor. Here we have G cap, which is connected between out and 0. Type is capacitor, right? You can see the capacitor, and this is controlled in a PWL manner. And this is connected again. These two are the independent connection, right? The nodes PTRL and 0. Then we have 2 volt 1P and 2.5 volt 5P. Beyond the voltage capping levels, capacitance values are capped at 1 picofarad. This is capacitance value picofarad, and 5 picofarad. This is 5 picofarad respectively. In between, it varies linearly. So this is quite complex. Here the examples that you see, that these are very complex sources. These are not very simple and straightforward. So it will take time for you to understand these sources, and if required, you have to write the equation by understanding these examples. That's why I have given a couple of examples for you to understand. Now we are done here. Let's move on to the next slide. Current controlled current source. So here the ultimate source is a current source, and it is controlled by current, which are the independent sources. Now the syntax is F, then we have alphanumeric, 2 nodes in between which it's connected, type, then we have gain, max and mean value. Type can be CCCS, then PW and poly. Max and mean are the lower and upper capping limit of the output voltage. That means the final voltage. Example, we have this equation, right? I F1, this is 5 into IV sense, represented by spice. So here you can see F, then we have 1, which is connected between 13 and 5 node, and this is controlled by V sense. And max and mean are plus 3 and minus 3. These are, so remaining is gain, and gain is 5 here. So you can see this 5 comes as a gain at this point. Next equation is I, then F2, then 1E minus 3, then we have this IVCC, and it is spice syntax is F2, then it is connected between these two, and this is the polynomial equation. So we have poly, right, and then we have VCC 1A and 1.3 M, 1 million, 1.3. So this way you can define the things. We are done with the examples of current controlled current source here, and these are again quite complex things. You have to put your mind in a calm state and then understand and then write the syntaxes. Done here. Let's move on to the next slide. Now we will be talking about the current controlled voltage source. That means the final one is the voltage source, and it is getting controlled by the current. So here is the syntax. Each, then we have the alphanumeric presence, then we have 2 nodes, type, and then we node 1, and then we have transconductance, max value, mean value. We already know these types. Type can be CCVS, PWL, poly. Max and mean are the upper and lower limit of the output voltage. That means the final voltage. These are the capping limits. Example, here we have a equation Hx 1000 into V current, represented by the spice syntax, this one. Hx here, and then these 2 nodes are here. V current is there, which is this, and max and mean value, that is the capping value, and finally we leave the value 1000 which is coming here. We are done here. Let's move on to the next slide. Let us summarize what we have learned today. We have learned about the polynomial source 1D and 2D. We have talked about voltage controlled voltage source with examples. Next, we have talked about voltage controlled current source with example. Next, we have talked about current controlled current source with example. And finally, we have talked about current controlled voltage source with example. So these are the things we have covered in today's episode, and we are done here with the summary slide. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in comment in the comment section down below, and bye for today.